All right, so what we're doing in this unit is everything to deal with measurement as far as angles go between different shapes. So first of all, today our goal is I can determine missing measures of angles using angle properties. And some of these angle properties you've been looking at for actually years already. So this is section 5.1, all about angles. All right, so first of all, we have different angle theorems, and they're called different angle theorems because someone has taken the time to prove certain things about them. Now, the first one has to deal with if I start here and go all the way around. Okay, if I start here and go one full revolution, well, you know how many degrees that is worth. That is worth 360 degrees. Now, what that allows us to do then, if we have a question where they have given us an unknown, in this case x, and if we look, it is the exact same all the way around. You can see it is all the way around is 360. Now, obviously, they don't give us the whole 360. They tell us that we have 340 degrees and they ask what x equals. Well, it's actually quite easy to do, right? Because it's just 360 take away the 340. So in this case, it would just be x equals 360 take away 340 for a grand total of 20 degrees. Now, could I have done that just in my head and just put 20 degrees? I could have, but this for our notes then just helps us to look back so we know exactly how we got that x. The next angle that we're going to look at has to do with 180. Again, what happens here is you can't actually see where the vertex of our angle is, but it's here. And if I start here and go all the way around, I know that that's 180 degrees. And what that allows me to do then is if I have a question like this and they ask me to find x, I know that the distance all the way around here is 180. And often this is one that we use an awful lot when we're solving different angles in different shapes. If we find a straight line, we know that the sum of the angles of a straight line equal 180 degrees. So in this case, if I want to find x, same kind of process in the sense that, so I get my pen to go where I want it to go. I have 180 degrees. That's an X. It doesn't look like an X though, making it look worse. Okay, so X in this case equals 180. Take away the 110. Take away the 30. So I'm actually taking away 140 for a grand total of 40 degrees. So pretty easy arithmetic there. Now the next one has to do with a right angle. Now a right angle, we use the square box in the corner. It, even if it looks like it's right angle, if it does not contain that square box, if it doesn't contain it, then you cannot assume that it is 90. Okay, although you might think it might not be. And there it is, 90 degrees. So this time when I want to solve for x, again, it's the same kind of process. X is going to equal 90, take away 75. And when we do that, we know that it is 15 degrees. And the last angle property we use special language for it, and it's called OAT, which stands for opposite angle theorem. It's an actual theorem, or sometimes we refer to it as the X pattern. And I'm just going to write that down, what that stands for. So it stands for opposite, make that thinner so you can read it better, opposite angle theorem. And often what we're doing is we're looking for an X pattern. And you can see there's an X pattern here. And what that means is y equals y. The opposite angles are equal to each other, and x equals x. So if I look at this question here, it's very simple. I don't even have to do any calculation. I know that x equals 60 degrees because it has that cross, that x pattern there. Now, often what we do with other angle properties and angle theorems is we often look for certain shapes. So here I'm looking for an X pattern, and now what we're going to look at is parallel lines. And if you notice, I have other letters. And the reason we do that is it's just a little bit easier to find things. So again, this is a review. You have looked at parallel lines before and the angles in elementary school. So what it means is if I have two parallel lines, you can see parallel lines, and we denote parallel lines with these arrows. Notice the arrow isn't at the end. So I'm not telling you that this line goes on forever and ever. I'm telling you that these two lines are parallel to each other. Okay, and we have what we call a transversal, and this is a transversal. Transversal is just another line that intersects, crosses two or more parallel lines, or actually any two lines for that matter. Now, when we're talking about alternative angles, we're talking about a Z pattern. Now, the reason I have more than one diagram here is because the Z pattern happens in more than one place. And what it means is if I have an angle A and an angle B, a C, and a D, it says if I have a Z pattern, and the Z pattern, when I'm looking at it, has to have the parallel lines on the top of the Z and the bottom of the Z. Okay, so those two lines have to be the parallel ones. If I can find a Z, then that tells me which angles are equal to each other. So in a moment, I'm going to now show you that A equals B, and the reason is because of the Z pattern that goes between, and I'm just going to bring up a highlighter for us to see that, and we'll highlight it in green. So here's the Z pattern. See, there's the parallel line down through the transversal and then across here again. Okay, so there's the Z pattern. And we also have a backwards Z pattern. So it's a flipped over one. So over here we also have a Z pattern, and that tells me that C equals D. Oh, good, it stayed on there. So here was C, here was D, and I know C equals D, and in this case A equals B. So these ones are kind of nice ones because I don't have to do any calculations. If I can recognize the pattern and if I know A or B, then I automatically then can write down the answer. Now, the next kind of angle that we want to look for is what we call corresponding angles. And again, they're dealing with, you have to have parallel lines, and we're looking for the F pattern. And the F pattern can be turned many different ways as well. And the first thing that we want to look at that I find is helpful too, so that we understand, just like when I looked at the Z pattern, the F pattern, what we're looking for is the parallel lines this time are the top part of the F and the middle one probably, and you're looking at directly underneath those parallel lines. Okay, so those are the angles that we're looking at when we're talking about corresponding angles. And what's nice about them as well is they are equal. Okay, so if I know one of them, then all I have to do is find the F pattern and then I have the other one. So again, what I'm going to do is this time I'm going to label different in the sense that I'm going to label more of the angles, A, B, and we'll do C, D, E, F, G, and H. So you can see that when I have two parallel lines in a transversal, it actually creates quite a few different angles. So now if I'm looking for F patterns, what I'm looking for, again, I'm going to go to my highlighter and we'll do blue this time. So I'm looking for an F. A typical F obviously is here. which means that this angle is equal to this one. Okay, another one would be the mirror image of that other one. So in other words, if I flip it around, so here's an F pattern backwards, and that would mean this angle equals this angle. And then if I look at two other possibilities could be an F pattern like this. And if I have that, remember it has to do with right underneath the parallel line. So we're flipping over our pictures. And again, we have another one here. Okay, so you can see the F patterns. So there's actually 4 different F patterns when we have parallel lines with a transversal like this. So what we end up having, again, is just bring back our pen. We'll do green. So in this case, this was D and H. So D equals H. This one here is C and G, and they are equal to each other. And if we look here, we have B and F are equal to each other. And finally, the last F, we have A and E are equal to each other. Okay, now we also have some other properties dealing with parallel lines, and that's what we call co-interior angles, and it's the letter C. So I'm making a square C, and so we're looking at the parallel lines being on the top of the C pattern. Now what's different about these are not equal to each other, so this is kind of important for this one in the sense that you can see that there's a C pattern here, and I should have used the highlighter because it's a little thicker. And if this is A and B, what happens is A plus B equals 180 degrees. Okay, so as I said, it's different. It's useful sometimes to us. And the other C pattern is over here. And if we call this C and D, again, C plus D equals 180 degrees. Okay, so we're always looking for those patterns. Now, one thing about dealing with any of these types of questions, take the picture, and if you can't see it, if you notice, for instance, my examples here, I've changed the orientation of where the parallel lines are. And so what you want to do is you want to, if you can't see right away those patterns, the X, the C, the Z pattern, or F pattern, what you can do is you can actually turn the page. Okay, now because I have mine, I think, see, I can actually flip mine around if I so wished. But you can do that with a piece of paper as well. So what we're going to do now is we're going to solve all these unknowns in these two examples, and I'm going to do that in the next part of the video.